Okay, number eight on the 7.5 homework. Okay, I'm gonna look at the first equation. On the first equation, it has an x squared and a y squared, which you should recognize as the standard form for a circle. So the center would be at 0, 0, and the radius would be 3, because it's the square root of 9. Let me sketch a circle. Okay, so center 0, 0, radius 3, so here, and make it kind of roundish. Okay, this second equation has an x squared, but not a y squared, which means it is not a circle, it's a parabola because it only has one of the variables squared. I'm going to rearrange it. Switch the inequality because I'm dividing by negative. So this is a vertex at 0, -7. Okay, it goes something like this. This is solid, right? Yeah, this is also solid. So let me sketch my parabola, and I totally ignored the shading, so let me go back. Okay, so for x squared plus y squared is less than or equal to 9, you can think your shading where the radius is less than or equal to 3, or if you learn to check a point, if I plug in 0, 0, 0 plus 0 is less than 9 is true, so I'm shading inside this circle. I'm just gonna mark it inside circle, or in your head, mark it inside circle. For the parabola, y is greater or equal to x squared minus 7, so above the parabola, or if you plug in 0, 0, that's fine. So let's see, that would be kind of inside. Okay, so inside the parabola and inside the circle, which gives me this region, and here is my solution region. I see 4 vertices. These are all solid lines, so I'm going to put closed circles at each one. Closed circle, closed circle, closed circle, closed circle. And let's see, this is where the circle meets the parabola. You could do substitution or you could do elimination. I'm going to do substitution just because on the solutions I did elimination. Okay, now if I look at this one right here, if I solve for y, I can do that. If I solve for y, I would have to plug it in here, and I'm going to have to square it. If I solve for x squared, I can substitute it into here, and it's going to be easier for me. So I'm going to change this to x squared equals y plus 7. And then I can make the substitution for x squared. And I did it with elimination on the solutions, if you want to see it with elimination. Okay, let me just put this in order. Y squared plus y, 7 minus 9 is -2. Okay, I get y equals -2 and y equals 1. Let me see, which one do I want to plug it into? I'll plug it into the x squared equals y plus 7. X squared equals y plus 7. X equals plus or minus root 5. Okay, so at positive root 5, -2, that must be over here. And then negative root 5, -2 must be over here, just because those are that's the only one that makes sense. Okay, now let me plug in the 1. X squared equals y plus 7. X squared equals 8. X equals plus or minus root 8, which simplifies to 4 times 2, plus or minus 2 root 2. So y equals 1, x is positive, negative root 2 root 2. So that must mean this is 2 root 2 comma positive 1, and this is -2 root 2 comma positive 1. And I just used kind of the quadrants to deduce which one went in which location. Okay, last one was a word problem, but I made you graph it. But I'm showing you how now. Okay, I'm going to go to the question before I read it again. So it says, then write and graph a system of inequalities that describes the different number of tickets that can be sold. And that's because that way I can go back and figure out what the types of tickets that are sold are. So let me read. For a concert event, there are $30 reserved seat tickets. So the first type is reserved seat tickets, and I'm randomly giving it an X or a Y. And $20 general admission tickets, so that must be my other type. Admission ticket. There are 2,000 reserved seats available, and fire regulations limit the number of paid ticket holders to 3,000. The promoter must take in at least $75,000 in ticket sales. To find the variables, then write and graph a system of inequalities that describes the different numbers of tickets that can be sold. Okay, now let me go back and look at the information they give me so I can actually write some inequalities. Okay, the reserve tickets are $30. The general are $20. Now, is there information restricting my money? 20, there it is. At least $75,000. So 30x plus 20y at least means it could be more than or equal to 75,000. Okay, let me read it again and look for the next information, blah, blah, blah. There are 2,000 reserved seat tickets available. Which one is reserved seats? Reserved seats are X. Okay, there's 2,000. So I might sell exactly 2,000, but I might sell less. I just can't sell more because there's only 2,000 seats. So I might sell exactly 2,000 or I might sell less. Anything else? Fire regulations limit the number of ticket holders to 3,000. So the tickets can't be more than 3,000 because the fire marshal says maximum 3,000 or lower. And ticket holders. Okay, well, there's reserved tickets and there's general tickets. Okay, I got all the information there. I'm going to sketch a graph. Obviously, because these numbers are very high, this is going to be a sketch, and we're going to assume that x and y are greater or equal to 0 because it makes it easier to graph. Okay, I'm going to graph using intercepts this time, and I'm going to show you how to do this in class, but preview, we'll do it now. Okay, let me see. I'm going to go backwards because it's easiest. Okay, I'm going to find the x and y intercept of this equation right here so I can get the boundary line. Okay, now if I want the x-intercept, I plug in 0 for y. If I plug in 0 for y, I get x equals 3,000, which means there's an intercept at 3,000, 0. I don't have to list it here. I'm going to put it on the graph, but I'm showing you it here. Okay, if I want the y-intercept, I put in a 0 for the x, and I get y equals 3,000. I'm not worrying about the inequality at the moment because I'm just doing the boundary line. Okay, I don't have any scale, so I'm just going to put 3,000, 0 here, and 0, 3,000 here, and then I'll erase it if it doesn't work out. Is this a solid line? Yes, it's a solid line, and I stay in quadrant 1, so it's going to be something like this. Now, in terms of which way to shade it, you could turn it into slope-intercept form to tell, or you could plug in a point. If I plug in 0, 0, 0 plus 0 is less than 3,000 checks, so I have to shade towards the 0, which is down here. So I'm shading below, and again, you don't have to mark it. This is how I remember. Okay, now I'm going to go to the next one. Okay, this one says x is less than or equal to 2,000. So x equals 2,000 is a vertical line through 2,000. Because I have no idea what's going on, and I don't have a scale, I'm just going to call this 2,000. X is a solid? Yes, solid. So x is 2,000 is going to go something like this. If the x's are less than 2,000, they must be going towards the lower x values, which would be on the left side. Okay, one more line. I'm going to use intercepts on my first equation as well, but it's going to be harder to do in my head. Okay, let me see. If I want the x-intercept, I put in 0 for the y value. So then I'll have 30x equals 75,000. If I do 75,000 divided by 30, what do I get? Is it 2,500? Okay, that's 2,500 for the x-intercept. If I want the y-intercept, I put in 0 for the x. Then I have 75,000 equals 20y, so I get 3,750. I'm going to mark them on the graph to get a decent approximation. So 0, 20, 2500, 0, I should say, is actually right in between here. 0, 3750 is going to be a little higher, maybe here. Okay, is this solid? This is a solid line. Okay, and then which way do I shade? Okay, if I plug in 0, 0, 0, 0 is not greater than 75,000, so I shade away from the origin. So I'm kind of above the line, which makes sense because it had a greater than sign. Okay, so below the purple, left of the blue, above the pink, it puts me into this teeny little corner right here. I need to use a different color or you're not going to know. No, you're still not going to know. Okay, so my solution region is in this teeny little corner. It doesn't ask me to find the vertices, fortunately, but that would be my solution region.